Hello. Here are some example problems of mean value theorem. We're going to do 3 of them, kind of different forms. The first one we're going to take a look at is y equals negative x squared over 4x plus 8 on negative 3 to negative 1. The MVT, remember, reads f prime of c equals f of b minus f of a all over b minus a, and we're guaranteed that as long as it is continuous, the function is continuous and differentiable on the given interval. So the reason I want to start with this one is take a look at what that denominator is and think about what that discontinuity would be. And in this case, because I have a discontinuity, a place where 4x plus 8 equals 0, at negative 2, and negative 2 is on that interval, then I can't use MVT. And so that's what you'd say. You can't guarantee a C because MVT requires that there is no discontinuity on the interval, and in this particular case there's a discontinuity to x equals negative 2, which is on negative 3 to negative 1. So you can't use it. Okay? Look at a couple where you can use it. If we had y equals positive x squared over 2x minus 4 on negative 4 to 1. Again, I have a discontinuity on this function, but my discontinuity is at 2. And 2, you'll notice, is not on the interval, so I'm good to keep going. Okay, so I need my f prime of c first, my derivative. So we have our low, d high, minus our high, d low, all over low squared, which simplifies when I distribute this 2x in to 4x squared minus 8x minus 2x squared. And one step further to 2x squared minus 8x all over 2x minus 4 quantity squared. Okay? So we're there. Next up, we've got our f of b minus f of a over b minus a. My f of 1 minus f of negative 4 all over 1 minus negative 4. Or in this case, it really would be y of 1 and y of negative 4, because to find these f of 1's, f of negative 4's, we're plugging into original function. When I plug in 1 up here, I get negative 1/2. And when I plug in negative 4, I get negative 4/3. All over my 1 minus negative 4. Okay. Negative 1/2 minus negative 4/3 is 5/6. And 5/6 divided by 5 is 1/6. Okay, so next step, we've got our f prime of c over here. And I'm going to set it equal to my f of b minus f of a over b minus a, this 1/6 there. Okay. I can tell you right now that this would be a calculator question. If it was a non-calculator question for some reason, there are different options you could have here. You could potentially cross multiply, you could subtract the 1/6 over and find a common denominator. I'm sure there are other algebraic steps, but because this would be a calculator problem, I would recommend don't take any extra mathematical steps that you don't have to. If I can get this to equal 0, I can solve it. And so I'm going to go ahead and just subtract that 1/6 over to the other side. And I'm going to put this into my y equals. So we have our 2c squared minus 8c over 2c minus 4 quantity squared minus 1/6. Okay, so window, I'm going to go ahead and constrain my window to -4 to 1. The reason why is that it's always the chance you might end up with some zeros that are outside that window. And while I know that and you know that, if you constrain the window in your calculator to begin with, you don't run the risk of accidentally forgetting to not include a number outside the window. If you can't even see it, you won't accidentally write it down as an answer. So I'm going to go ahead and constrain my window so I really only see the zeros that could potentially be answers in this particular problem. And so when I graph that, see it working its way over, it's getting closer and closer and closer to a 0. And right there, I see it cross. Right here. Okay, and so I'm going to go ahead and do second calc. Graph that 0. I have a left bound and a right bound. And a guess. And I find that I have a 0 at -0.4494897, or -0.449. Okay. Let's go ahead and do 2 more. I know I said at the beginning that we were going to do 3, but I don't really count that first one as being its own. It is its own example, but when you think about having to go through the whole process of mean value theorem, it's not its own example. The first one is just to make sure we're still reminding ourselves of the fact that we do need to make sure we've checked continuity and differentiability on the interval. Right? Okay, so let's go ahead and do then our y equals, and we've got -x squared plus 8x minus 17 on 3 to 6. Okay. So f prime of c first, we have our derivative, -2x plus 8. And then our f of b minus our f of a over b minus a. F of 6, when I plug in 6, I get -5. When I plug in 3, f of 3, I get -2, which is -1. So then we take our derivative, our f prime of c, we set it equal to our -1, our f of b minus f of a. And in this case, because I only have the one x, I'm allowed to solve this any algebraic way I'd like. This would probably not be a calculator problem. And so I'm going to go ahead and subtract this 8 over. I get -2x equals -9, and divide by that -2. 9/2. It's a good idea to always make sure that you haven't made a little small mistake, because again, this number should be on this interval, which it is. 9/2 is 4.5, which would lie between 3 and 6. If for some reason I had gone through all this process and I got 8 as an answer, 8 is not in that interval, which means somewhere there was a mistake. MVT, we are guaranteed we will have a C somewhere between my 2 endpoints where this derivative equals my f of b minus f of a over b minus a. It's got to happen, unless there was a discontinuity or not differentiability on the interval. So that's what you check for. Did you miss a discontinuity on this interval or a not differentiability on this interval? Did you make a small algebraic error somewhere, add, multiply, subtract wrong, something like that? But you're going to get at least one answer, sometimes more than one, but you're going to get at least one. And so make sure you kind of use that as a check there for you. Okay. Let's go ahead and do one more. We have y equals, it's up here, y equals -x cubed plus 4x squared minus 3 on 0 to 4. Okay, so derivative first, -3x squared plus 8x, and then f of b minus f of a all over b minus a. When I plug 4 in, my f of 4, I get -3. When I plug in 0, I get another -3. which means 0 is going to be my f of b minus f of a over b minus a. So I'm going to take these, set them equal to each other. Negative 3x squared plus 8x equals 0. Okay, I can factor this one. Get negative 3x plus 8 because it equals 0. As long as it equals 0, I'm allowed to factor. Okay. And so then we get 0 and 8/3. Except I cannot include my endpoints as an answer, so it's not 0. The only guarantee I've got is 8/3.